Today's connected device applications are increasingly complex systems of systems involving devices, networking, services, and applications. Cordant provides a comprehensive standards-based IoT stack to let you focus on value-added solutions instead of technology infrastructure. Let's walk through an example use case to illustrate the power of the Cordant platform. Let's consider an end-to-end food supply chain. It might start at one of dozens of farms, where a farmer raises chickens under carefully controlled conditions. He transports them via truck to a regional distribution warehouse. At the warehouse, the food is checked into inventory, stocked, and pulled for shipment. Refrigerated trucks transport the products to restaurants, retailers, and grocery stores, where consumers finally purchase it. Managing quality and carefully controlling conditions along this chain is critical to ensuring the products arrive at their destinations and for optimal freshness and safety. A food supply chain like this might involve multiple devices, networks, and back-end services. Each disparate element is tied together through Cordant's dynamic messaging platform, while one M2M represents the data in a uniform way and opens up access to advanced core network features. Let's explore how a solution like this might work. Our farmer has a smart coop system to record environmental telemetry and to control critical variables like ventilation and lighting that affect his yield of chicken and eggs. An embedded MicroPython-based controller connects with a LoRa radio gateway, just one of many networks supported by Cordant. Temperature, humidity, and ambient light data is measured and sent to the LoRa gateway and onto a LoRa network server from Actility, and then integrated into Cordant's message bus. Backend services normalize and analyze the data, but sometimes the farmer is on the road, delivering his product to the regional warehouse. He checks on the farm with his phone, deciding to open the vents. The command flows through Cordant's messaging fabric, translating between LTE and LoRa networks. Meanwhile, inexpensive Bluetooth-based sensors in his crates continue to monitor the temperature during transport, using the farmer's phone as a gateway to relay the telemetry to the same one M2M service that was available back at his farm. At the warehouse, the products are loaded onto connected pallets equipped with NB-IoT radios. The radios are registered in Cordant's device management system. Each pallet reports its location in the warehouse and continues to monitor environmental conditions. A Wi-Fi connected gateway runs a 1M2M CSE and other Cordant services at the edge. These managed edge processing containers communicate with Cordant's cloud to track telemetry and manage inventory, directing workers how to pick and load orders for delivery. A Qualcomm BG96-powered device maintains temperature monitoring and inventory tracking during shipping. The embedded 1M2M AE in the device communicates with the Cordant platform using LTE Cat-M1. Device firmware is easily updated using Cordant's firmware over-the-air functionality. Detailed configuration like reporting cycle and the associated power consumption can be managed by sending commands through the 1M2M bindings to the SCEF interface of the LTE core network. This local restaurant, the first stop on the delivery route, marries consumer-grade IoT devices to the carrier-grade systems and infrastructure provided by the Cordant stack. Sensors manage energy use, track temperature, and allow easy order placement over Zigbee, while Cordant handles all the integration to ensure the messages get routed back to the distributor and farms. At the supermarket, backroom storage conditions are tracked by a Wi-Fi connected device, sending data directly to a Cordant Cloud API, skipping a local router this time. Of course, it's all mapped into the right place in Cordant's 1M2M resource tree. Even in the simplified supply chain example, we've seen how quickly the complexity can multiply in and across each layer. Only a full-stack IoT platform like Cordant can provide the containerized edge processing, messaging, connectivity, firmware over the air, and embedded libraries on the edge. Tight integration with the data and control planes of PAN, LPWAN, and WAN networks. And the messaging platform, service orchestration, and integration framework, all exposed via the industry's leading implementation of the 1M2M standard. So you see, the Cordant platform is built for complex systems of systems with any topology, just like real-world connected device use cases.